boys and girls, and welcome to week 4 of distance learning. I hope you're doing good on your math, and I'm missing you in the classroom working across the table from you. We are going to continue working with fractions again this week, and we're going to add on to what you learned last week. Last week you were working with finding equivalent fractions, and this week you're going to take that knowledge of finding equivalent fractions, and you are going to add and subtract fractions that have denominators, the bottom number, that are not alike. So without further ado, I'm going to flip over to our SMART document and we're going to work on some problems together. So just some quick review. Last week I got that song hopefully stuck in your head about wanting equivalent fractions. So just again, some quick review. If I've got the fraction 3/4 and I want to find it differently, and I want to find it with a denominator of 12, I can come over here and I can skip count by 4s. Using your multiplication chart, you could follow that across. So you could have 4, then the next number would be 8, and then you would have 12, 16, and then 20. But I'm going to stop there because 12 is here. So 4 times what gives you 12? Times 1, times 2, times 3. So the 3 goes here. This needs to be a form of 1. If I have candy bar and it's cut into 3 pieces, how many would I have to eat the whole thing? I would have eaten 3. So then I'm going to multiply across the top just like I did the bottom. So 3 times 3 is 9. So 9/12 is equivalent or equal to 3/4. Hopefully after last week's practice, I gave you plenty of worksheets for that. Hopefully you're very comfortable with the skill. If you're not, you need to pause the video right here and you need to get in contact with me. You've got my email, your parents have my cell phone, because if you're not comfortable with this skill, you're really going to struggle with this week's lesson. So again, if you're not comfortable, pause and I need to hear from you. So this is this week's lesson then. If you take a look, we have the fraction 4/8 plus 1/4. Well, when you take a look at that, those denominators, the bottom numbers, are not the same. I've got something that's cut into 8s and I've got something that's cut into 4s. So if you can just picture something, picture a pizza or picture a candy bar. They're cut into 8s, they're cut into 4s. The piece sizes are not the same. And when they're not the same size, you cannot add or subtract them. So the first thing you have to do is you have to change them so that the piece sizes are the same. How do you do that? We want equivalent fractions. So it's not going away. So as always, I expect you to be working through these problems with me. Didn't tell you that before, but hopefully by week 3 you know. So you need your pencil. You need your multiplication chart. And this template right here is on the Google Slides. I've got multiple math slides again this week, so you might have to scroll back and forth between those Google Slides to be able to find them. You do not have to print them, though. You can just copy this down. It's a template. The idea is that you just get used to what it looks like, and you are able to fill in the information, and it gets stuck in your head how to figure out this problem. So let me show you what it looks like, and we'll solve some problems together. So here we go. My first fraction is going to go up here. I've got 4/8, and then I want to add 1/4. Again, my denominators are not the same, so I cannot add them yet. So I've got to find some equivalent fractions. You probably wondered why last week there were two number lines down here. Here's why. I'm going to take my first denominator of 8 here, and my second denominator of 4 down here. Doing the same concept as last week. You're just having to do double the work twice. Okay, so following your 8 across on the number on your multiplication chart, we need the multiples of 8. So 8 times 2 is 16. We're skip counting. And then 16, the next one would be 24. I'm going to stop there because, one, I'm running out of space. I'm hoping that that's far enough. I can come back to it if not later. Okay, skip counting by 4s. I've got 4, The next one is 8. And I'm going to go ahead and stop there because look, here is exactly what I need. Oh, here we go. I see that 8 and 8 are in common on both of those. That tells me that that is going to be my new denominator. So, coming over here, my new denominator is going to be 8. Do you see that equivalent fraction work coming back from last week? Just for fun, I'm going to come down here at the bottom. 4 times what equals 8? I can look here. Times 1 times 2. You can use your multiplication chart as well. So my 2 goes here. This needs to be a form of 1. So if I cut my candy bar in 2 pieces, how many would I have had to eat the whole thing? It would be 2. Multiply across the top. 1 times 2 equals 2. Okay. 8 times what equals 8? Don't be tricked by this. It's just 1. This fraction is actually not going to change. A form of 1. 1 over 1 is 1. 4 times 1 is 4. See? Didn't change. 4 eighths and 4 eighths. Okay, I'm going to look back up here because this form is actually made for addition and subtraction. So I'm going to look back up here. I'm adding these. So I'm just going to mark that. I'm adding those. Okay. Now, remember when you're adding, you only need to add your numerators. So I'm going to look at 4 plus 2, which gives me 6. I mark my answer up here, 6. And the bottom number, the piece size, stays the same. So my answer would be 6 eighths. Let's try another one together. I've got 2/3 plus 5/6. I cannot add them just the way they are because my piece sizes are not the same. So I'm going to write my fractions down here on my template. Oops, sorry. Be patient with me there for a minute. Okay. Then I'm going to take both my denominators and I'm going to put it down here and find the multiples. So I've got my 3 and I've got my 6. Skip counting by 3s or following your 3 across on the chart. You've got 3, oh my goodness, my computer today, 6, 9, 12, and 15. Can't be the user, could it? Okay, skip counting by 6s. I've got 6, 12, and I'm going to stop there. I actually see 2 multiples that they have in common. There's 12 here, but then I also see 6. We want to go with the least number, the least common multiple, so the lowest number. So we're going to use the 6 here, which is going to be our new denominator here. So it goes over here for our equivalent fractions. And again, this is like last week's work, just times 2. So 3 times what gives you 6? Times 1 times 2. Okay. What form of 1? If you've cut your candy bar in 2 pieces, how many pieces do you have to eat the whole thing? 2. Multiply across the top. 2 times what? 2 times 2 equals 4. 6 times what is 6? Again, don't let that throw you guys off. It's just 1. Don't overthink that. This is going to be 1 as well. 1 times 5 is 5. When you add your fractions with like denominators, you're only adding those top numbers. So you've got 5 plus 4 gives you 9. Your bottom number, your piece size, stays the same. So it's going to be 6. Now I could leave it like this, but I also notice that this is an improper fraction. So I'm going to go ahead and remind you to do a little bit of work like this. 9/6. What would it take to make 1 whole? Oh yeah. 6 over 6 equals 1 whole. Oops, wrong one, Mrs. Spitzley. 6 over 6 makes 1 whole. And then how many pieces would I have left over? Because I had 9, 6, 7, 8, 9, 3 more pieces. Get my plus sign in there. So I'd have 3 more pieces left. Boy, it's not wanting to work with me today. Okay, so this is my 1 whole right here. So 9/6 is the same as 1 whole and 3/6. You will come up with some of those problems this week. You can leave them as an improper fraction, but because we spent so much incredible time on that in the classroom, I'd really like you to challenge yourself to turn those into a mixed number for me, please. Let's take another look here at 1/5 plus 1/6. Again, denominators are not the same. I'm hoping you're feeling a lot more comfortable with this. Computer is not wanting to cooperate. I apologize. I hope you're not getting a little antsy at home. If you are, you can always just pause the video here. You can work until you get stuck, and you can check back with me. But I did choose this problem on purpose because it's a little bit more challenging than the others. The others followed a pattern that this one does not. All right, 1/5 plus 1/6. Denominators are not the same. Piece sizes are not the same. We need to find some equivalent fractions. So I'm going to take these bottom denominators. I've got 5, I've got 6, and I'm going to do my skip counting. 5s are easy. 5, 10, 15, and 20. And then I'm going to look at my 6s. Okay. I've got 6. Following that across on your multiplication chart, your next one would be 12. 6 times 3 is 18. And then times 4 would be 24. And then the next one would be 30. Okay. Now I'm going to take a look there, and I'm going to compare. And I'm starting to panic just a little bit because none of them are in common. Then I realize I have a blank here, so I better go fill that in. 5, 10, 15, 20, 25. Does that help me? No, it doesn't. All right, so even though this template has 5 blanks, you're not always going to come up with your new denominator within those 5. So it looks like you're going to have to extend this just a little bit. So let's see. This is all the way to 30. This one's not there yet, so I'm just going to go a little bit farther with the 5s. 5, 10, 15, 20, 25, 30. And that was the magic number for us. Do you see the least common denominator? Yep, I see it too. Here's the 30. So that's going to be our new denominator is 30. Now in the previous problems, it actually was one of the existing denominators already. Do you see that? It ended up being the 6. It ended up being the 8. And this one, it didn't end up being the 6 or the 5. We had to go pretty far out. And we even had to extend our lines to be able to get it. All right, so 30 is our new denominator, and then we're going to find equivalent fractions and add from there. So 5 times what gave us 30? 1, 2, 3, 4, 5, 6. 6 over 6 is our form of 1. 1 times 6 is 6. 6 times what gives you 30? Times 1, times 2, times 3, times 4, times 5. Or again, your multiplication chart. 5 over 5 is your form of 1. 1 times 5 is 5. Now our piece sizes are the same, and we can add. Again, you just add your numerators. So you've got 6 plus 5. 6 plus 5 is 11. And your denominator stays the same, so it is 30. All right. Next, I'm going to show you 3 different subtraction problems. Subtraction is just a little bit easy in that you're not going to end up with a problem like this, where it's improper and you have to turn it into mixed. So maybe I'll only show you 2 of these. I've got 7/8 minus 2/4. Again, are you tired of hearing it yet? Denominators are not the same, so you've got to change it to a like denominator. All right, so I'm going to bring down those denominators, the 8 and the 4. Maybe you're even starting to see this just a little bit. So 8, skip counting, 8, 16, next number is 24. And I'm going to stop there because that's pretty high already. I'm going to start skip counting by 4s. 4, 8, 12. I'm going to stop because I already see it. It is 8. So that's our new denominator. I'm going to bring that up here into our equivalent fraction area. And look, here we got it again. 8 times what gives you 8? It's just 1. 1 over 1 is your form of 1. 7 times 1 is 7. This fraction did not change. 4 times what gives you 8? Times 1 times 2. 2 over 2 is your form of 1. 2 times 2 is 4. I failed on the last couple problems to mark this. So I'm going to go back up. This is a subtraction problem. That's just about the only way you can trick yourself at this point. Remember, for adding and subtracting, you're just looking at those numerators. So 7 minus 4. If you're counting up, it's 4, 5, 6, 7. If you're counting backwards, it's 7, 6, 5, 4, 3. Either way, you come up with 3. 3 is your numerator. And your denominator, stays the same. So your answer is 3/8. I'm going to skip to the very last problem here. And it is 2/3 minus 1/2. I hope you're continuing to try these on your own at home, pausing the video if I'm going too fast for you. Can we subtract this as it's written? Nope, because, right, the denominators are not the same. So we're going to bring this down, the 3, and then the 2, and we're going to skip count. 3, 6, 9, 12, 15, and then skip counting by 2s. 2, 4, 6, 8, 10. Take a look at that. Which multiple do they have in common? And if there's more than one, what's the least? Good job. It is the 6. So we're going to look at that. And then you know that that comes up here. It is going to be the denominator for our equivalent fractions. 3 times what gives you 6? Use your chart. Use down here. It's times 1 times 2. My form of 1 here. 2 times 2 is 4. 1 times what gives you 6? Times 1 times 2 times 3. We're using your chart. 3 goes up here. It's my form of 1. 1 times 3 equals 3. I'm going to go back up here to remind myself if I'm adding or subtracting. I am subtracting. Again, this form was built for both. And I'm going to just circle those numerators. That's all you need to focus on. 4 minus 3. 4, 3, 2, 1. Or if you put that 3 in your head, you're going to count up. It's 3, 4. Any way you do it, you get 1. And your denominator stays the same. And it is 6. So 2/3 minus half equals 1/6. All right, Okay, I hope that lesson made sense to you. Again, if you get stuck on those, I'm available through email. I'm available to model with you. I can go through a Zoom lesson with you. Your parents also have my cell phone number. I want you to be successful so that as you head into middle school next year, you will feel very confident in your math skills. You have all made amazing progress this year, and I want you to continue to work hard so that you are just confident and amazing math students as you head into sixth grade next year. Work hard this week. Work until you are proud of your effort and know that you're loved. Have a great week. I'll see you next week.